All right, so y is equal to ln the root of 2x squared plus 3 is the same as saying y is equal to ln 2x squared plus 3 raised to the half power. Tell me if you agree.
Yes, sir.
Now I'm going to push the power to the front, which is something I can do with logs. So I'm going to have y is equal to a half ln 2x squared plus 3. Do you agree?
Yes, sir.
Let's differentiate dy by dx. Let's leave this half here. If I differentiate ln, I'm going to get what? 1 over 2x squared plus 3. Then I have to multiply by the differential of the inside function, which is 4x. This 2 cancels this 4 2 times. So my final answer is going to be 2x at the top. And at the bottom, I have 2x squared plus 3. As I said, it becomes easy if you deal with it from your understanding of logarithms. All right, did anybody get it?
Yes, sir.
You did? Is this the approach you took to it? Ariana?
Yes, sir.
Very good. All right, differentiating exponential functions of the form y is equal to a to the x. So let me show you how to do this. Then I'll ask you.
I didn't take that route. I guess maybe that is why I did not get it, or I did something I should not have done.
I find that it is possible to take a different route. It's just that it would
What I
become more
did,
complicated.
what I did was still keep the half, and I had 1 over 2x squared plus 3 raised to the half times the derivative of 2x squared plus 3 raised to the half.
Right, you said you kept the half. So you have y is equal to ln 2x squared plus 3 raised to the half. You kept the half there, or you brought it to the front?
I kept the half there.
All right, so dy by dx would be equal to I'm coming. All right, let's just say 1 over 2x squared plus, no, this is going to make it super complicated. It probably could be worked out, but definitely not in the space that we have here. I would advise you not to do this, because when you finish, you're going to have to move from root to root of 2x squared plus 3 to 2x plus 3. So it's probably doable, but I wouldn't advise you to take that route. It's going to add complexity to something that could otherwise be simple.
Okay, sir.
All right. So here we have y. Maybe when I get another chance, another day, you and I can have a go at it. Y is equal to a to the x.
Sure.
All right, please look at how do we differentiate a function of this form. What we'll do is that we'll find ln of both sides. So I'm going to have ln y is equal to x ln a. Sorry, x ln a. What I want you to tell me is if you're okay with what I just did.
Yes,
Yes,
sir.
Fine. All I did was took ln of the right-hand side, and now the power would have been x, so I just simply push the x to the front. Please note, you see ln a is a constant. Ln a is a constant. Ln x, ln a is similar to, let us say, 3x. In both cases, it is a number multiplied by what? By x, don't it? Because ln a is just a number. A is a constant and ln a is a constant. So it's just a number multiplied by x. When you differentiate 3x, what do you get? Help me now. When you differentiate 3x, what do you get?
3.
3. So if I differentiate x, ln a, what do I get? Come on, guys, you're not quick.
X, sir.
No. If I differentiate, these two things are the same thing.
1.
3x, 3x and x ln a, they are the same thing, the same idea. It is the same idea of a number multiplied by x. If I differentiate 3x, I'm going to end up with 3. If I differentiate x ln a, what am I going to end up with?
1.
No.
ln A.
You're going to end
Oh,
up
yeah. Oh, my gosh. That makes sense.
ln a. You're going to end up with, if you differentiate a number multiplied by x, you're going to end up with the number. So if I differentiate both sides,
What you were trying to say.
if I differentiate both sides with respect to x, I'm going to get, differentiate one ln y, I'm going to get 1 over y. Then I have to multiply that by the differential of the inside function. The inside function is y. So when I differentiate y, I'm going to get dy by dx is equal to ln a. I'm then going to move this y come here, and I'm going to get dy by dx is equal to y ln a. But y is equal to what? A to the x. So dy by dx is equal to y, which is a to the x, ln a. So when you differentiate y is equal to a to the x, you're going to get a to the x, ln a. With that in mind, I want you to do example 10. With that in mind, I want you to do example 10.
Mr. What you said is your answer for example 9?
I think it's
Oh,
example
no.
9.
Example 10. Okay, sir. No.
Example 10.
So that's what you're doing now.
Example 10, yeah, man. I think it's 2 to the x ln 2. All right, so here we have y is equal to 2 to the x. Take ln of both sides, ln y is equal to x ln 2. Let's differentiate both sides with respect to x. So this is 1 over y. Dy by dx is equal to ln 2. We differentiate x ln 2 with respect to x, you're going to get ln 2. Bring this y over here. We're going to get dy by dx is equal to y ln 2. And so dy by dx is equal to 2 to the x ln 2. Now when x is equal to 2, dy by dx is equal to 2 to the 2 ln 2, and this is 4 ln 2, which works out to be 2.77. All right, let's turn the page and see what's around there. All right. This says differentiating logarithms of the form y. So let me show you how to do this. Is equal to log to the base a of x. All right. Let me show you how to do this. Then I'll ask you guys to have a go at example 11. Now, what you would do here is that you would move from logarithm form to index form. So showing you how to differentiate logs, you need to move from logarithm form to index form. So in logarithm form, a is the base, x is the number, and y is the power. So if I move from what log to index form, it's going to be the number, which is x, is equal to the base a raised to the power y. All I did was move from log form to index form. In logarithm form, a is the base, x is the number, and y is the power. All right, so moving now from log to index form, it is the number is equal to the base a raised to the power y. Then I'm going to take ln for both sides. So I have ln x is equal to y ln a. All right. I could then differentiate both sides. If I differentiate both sides, with respect to x, I'm going to get 1 over x. If I differentiate ln x with respect to x, I'm going to get 1 over x. If I differentiate y with respect to x, I'm going to get dy by dx ln a. All right, bring the ln a down to the bottom, and I'm going to get dy by dx is equal to 1 over x ln a. With that in mind, guys, can you please do example 11? All right, so example 11. All right, so what we have with example 11 is that y is equal to log to the base 10 of x. Let's move from log form to index form. And if I do that, I'm going to get x is equal to 10 raised to the power y. Then if I take ln for both sides, I'm going to get ln x is equal to y ln 10. Differentiate both sides with respect to x. I'm going to get 1 over x is equal to dy by dx ln 10. And so therefore, dy by dx is equal to 1 over x ln 10. Did you get it?
Yes, sir.
Did somebody say no, they didn't? All right. Let's just pause the video and let's do this one before we stop the video. All right, so example 12, we have y is equal to log to the base 3 of x. Now we can go from log form to index form. So 3 the base raised to the power y is equal to the number which is x. ln both sides, we have y ln 3 is equal to ln x. Then if I differentiate both sides with respect to x, I'm going to get dy by dx ln 3 is equal to 1 over x. And so dy by dx would be equal to 1 over x ln 3. All right. So that is how you differentiate a log function, or differentiate a log function of that form.